Okay, good afternoon, everyone. Let me start today's session with the work which I had given you in the previous session. I'll just glance over those assignment or the homework problems, and then I'll move to the next operation. This, what I have drawn, you can see it on the screen, is one of the homework given. I think x of n plus 2, I had asked you to solve. I had asked you to try at least. This is the given x of n. If you observe x of n, it is having how many samples? Minus 4, 1, 2, 3, 4, including 0, 5, 6, 7, 8, 9. So range is from minus 4 to plus 4. Some 9 values you have. At 0, 0 value. So totally 9 values. So if you shift n plus 2, total 9 values should be there. You cannot skip it. The skipping or the removal is possible only in time scaling. Okay, because when you divide or divide the thing, divide by that a value, some fractional time will come. During that, such samples should be discarded. But otherwise, in time shifting operation, in case of discrete signals, total number of samples in the shifted signal and the original signal should be same. Okay, so let us start. X of n plus 2. Okay, plus indicates left shift. As I had told you how to write n plus 2, it is n of n minus 2. This becomes n plus 2, right? So your n naught value is a negative value. Hence, your signal should be shifted to the left side by this magnitude is 2. 2 amounts. So 2 amount shift to the left side. Let us try that. I have marked here. Let me take a different color. Actually, signal is at minus 4. Okay, the lowest end, the leftmost end is at minus 4. If I shift the signal to the 2 amount by left side, see, this is 1 point, this is second point. So now I have to mark this minus 4 sample value at minus 6. I have done this here, minus 6. After this, this is completed. I have done this part. Color is not correct. Okay, this I have completed. How many samples are still remaining further? 1, 2, 3. After this minus 4 sample, we have 3 more samples. I have just now drawn this minus 4 sample at minus 6. Still 3 more I have to draw. I have drawn that continuously because 4 samples are continuous. If you observe here, 4 continuous samples are there, minus 1 amplitude. After that, if you check, you have a 0 sample, that is the sample amplitude value is 0 at 0 point. So after these continuous 4 samples, you have to mark a 0 sample. After this, continuously you are having plus 1 amplitude 4 samples. So mark those continuously 4 samples. So total, if you count, how many here? 4 plus 1, 5 plus 4, total 9. Here also, if you observe in your given question, you have got 9 samples. After you shift, you will get 9 samples. You cannot discard any of the samples in case of time shifting. The discarding operation, it is done only in case of time scaling. Let me show you how it is. Here, if you observe, when I divide it, some fractional values will come, 3 by 2, 1 by 2, like that. Under such cases, those sample amplitudes should be discarded, not this one. Otherwise, in time shifting, total number of samples should be drawn correctly. If you see here, x of n minus 4 amount of shift as it is negative sign to the right side. So what I have done, this count it 4 times, 1, 2, 3, 4. So at 0, I have marked this first sample. After this, how many are left? 1, 2, 3. 3 are left. After this, 1, 2, 3. Then a 0 sample. So 0, mark it. then continuously 4 samples are there. Those continuously 4 samples. See, total number of samples 4 plus 1 5 plus 4 9. So here also 4 plus 1 5 plus 4 9. So 9 samples to be shifted. See, complete figure, you just check it. There is a shift of 4 amounts. I hope you understood this problem. Similarly, coming to this problem, x of t minus 1. T minus 1 means you have to shift the signal to the negative sign is there to the right side by 1 amount. See, what is this? It is minus 1. So shift it to the right side by 1 amount means it should start at 0. Okay. If you count, how many units are there? 1, 2, 3. 3 units. The length of this slope is 3. So count it. 1, 2, 3. So the slope should be this. After that, there is one single unit down slope. So single unit down slope. So likewise, the length if you count, just to cross verify your answer, you count the length 1, 2, 3, 4. So 4 units have been used in x of t. Check here, 1, 2, 3, 4. 4 units have been used. I have not touched the amplitudes. I have simply shifted the signal by 1 amount to the right side. Similarly, check here, it is t plus 2. Plus 2 means to the left shift. Left shift by 2 amounts. So let me start that. The value is at minus 1. If I shift it to the left side by 2 amounts, 1 shift, 2 shift. This is your minus 2. This is your minus 3. So signal will start at minus 3. Now, how many units are there for this increasing slope? 1, 2, 3. 3 units. So use 1, 2, 3 units, increasing slope. After that, there is only single unit used for down slope. So use a single unit for down slope. Now count how many total samples are there? 1, 2, 3, 4. In actual x of t, 4 values. Here check it, 1, 2, 3, 4. So total length of the time is 4 units. So it is correct. Please make sure that amplitude should not be hampered. Time range of the original signal should be maintained. Like number of units used should be same. Don't skip the samples. I hope you understood this problem, these two work problems which was given as the assignment. Very good actually. Somebody has messaged me. I don't know their name. Probably it's Farooq. He has tried solving, I guess. No, not Farooq. I think it's Priyanka. Priyanka, she had messaged me. She at least tried. Very good. Keep it up, Priyanka. Well done. Let me go to the next, third type of operation performed on time. That is, we have completed time scaling and time shifting. We have seen in both cases how this is performed. Now let us go to the third operation, that is time reversal. Time reversal, it is also called reflection. So if you look at this word reflection, you might have already guessed it, what will be done here. See, when you stand in front of a mirror, your right hand will become left hand there, right? And your left hand becomes right hand. It appears to be. It is not exact. Actually, it appears to be the reversed. So here also, time reversal indicates why it is called reflection is because of this only. Why it is called reflection is because the time gets reversed. plus becomes minus, minus becomes plus. It is a reflection of the time. Let's see the definition. Let x of t be a continuous time signal. Then the signal y of t is equal to x of minus of t. Remember, negative sign is inside the bracket associated with the small t. X of minus t, it is called reflected version of x of t. Now it is important how to find x of minus t, that is reflection, how to find. Let's take one example and we will try to see how the reflection is performed. This is the given signal x of t. If you observe, the range is between -1 to 2. If you see, there is 1 unit, 2 unit, 3 unit. 3 units are used for increasing ramp and then suddenly a vertical line. This amplitude is 2. This is the given x of t. We have to perform x of minus t. How to do that? It's very simple. Whatever time you have, you observe what are the time values, simply put a negative sign before it. Okay, what is minus of -1? It will become +1. So what is the amplitude here? It is 0, nothing, there is nothing. Okay, after this the ramp is there, but at -1 it is 0. So what is the time minus of -1? It is +1. So at +1, no amplitude, 0. Then 0, you can't change it further. 0, -0, +0, everything is same. Leave it. Now coming to, I can take this also, but I don't know because I have not used the scale properly. I don't know what amplitude I'll get here, probably 1.2 or something I may get it. So let me, for this problem, let me skip this. Okay. If I would have used the scale properly, I would have got the amplitude correctly. But let me see. At 2, what is the amplitude? It is 2. If you put a negative sign before this time, it will become -2. Where is -2? -2 is here. At -2, this is vertical line, stretch it. And here from -1 to 2, there is a increasing slope. Here, see here, it is from -1 to 2, there is a increasing slope. But here from -2 to 1, there is a decreasing slope. In order to cross verify this, what you can do is, you simply take this figure, stand in front of the mirror, you will get this reflection. Okay, if you get this correctly, it means this answer what we have drawn is correct. You can do that, you can try that. Okay, now as there was ambiguity here, I was not knowing the amplitude here. So let me take one more example. It will be very much clarified to you. This is x of t given. If you see, there are many amplitudes. Here the amplitude is 1 for 1 unit. Here the amplitude is -1. Here there is a slope. Then here also 1. So it's a combination of all different amplitudes. Let's see how to solve this. Okay, what thing to be performed here? We need to go for time reversal, time reflection. In order to do the reflection, what we have to do, as I told you, take all these horizontal axis time values, take all these, put a negative sign before them. Okay, so let me start with say -2. We don't have anything here, so leave it. Let me take -1. Minus of -1 will become +1. So at +1, this vertical line comes. Vertical line comes. Okay. After this, at 0, there is one more vertical line. So at 0, 0 plus 0 minus 0, everything is same. At 0, one more vertical line. There is in between these two units constant 1. Hence between these two units a constant 1. So this block is flipped here to 0 to -1. How it is looking like? Earlier it was like this. Now, if you just simply flip it, it will come here. It's a mirror image, right? This is your mirror. Okay, center, vertical line, assume it as a mirror. This box appears to be in this direction. So that's what has been done. This box is coming here. Fine. This is about this point. This is over. Now, let us start with this. Now, if I apply a negative sign here, what will become? -1. So, time is -1. At -1, what is the amplitude? Here it is -1. So, I will simply stretch it. It is -1. Now, between 0 to 1, that 1 unit amplitude is -1. So, here also between 0 to -1, the amplitude is -1. How it is looking like? Let me show you the mirror image of a separate block. Earlier it is looking like this. Okay, let me draw it a dotted line because it is still continuating further. Okay, it has not ended like this. You have to still continue it. It is till this one, after that is slope. That's why let me draw this dots. Okay. If you take the mirror image of this, it looks like this. Dots. So that's why this block has appeared like this. Okay. So we have covered 2 blocks now. This one is over and this one is over. Now, after that, let me take this line. For this line, if you observe, it is decreasing slope. See here, it is 1 to 2. 1 to 2. There is a decreasing slope. Okay, -1 to, it is coming and coming down to 0. Decreasing slope. This unit now has to be reflected on the other side. If I put a negative sign on both the times, between -1 and -2, between -1 and -2, between these 2 points, I have to draw that. If I have this line, if I want to have a mirror image, its mirror image will be like this, right? If you stand in front of a mirror, check, this line appears to be in this way. Hence, this decreasing slope, here decreasing slope, coming to 0. So we have covered three points, first block, second block and third block. Now coming to one more block, between 2 to 3, we have this box with the amplitude 1. If I put a negative sign in the time, it is between -2 to -3. So between -2 to -3, this complete block should be drawn. This is how the complete mirror image of this looks like. What you do, you draw this, you try on the paper. After drawing, you go in front of mirror and stand with this figure. Try to check your answer with the actual mirror image what you get. If both matches, then your answer is correct. So it's a very good idea, right? Even during your examinations, you can do this if you have a wristwatch or so, because glass will be there. Hopefully, you will not do that. So these are the 2 examples for time reversals. Don't get afraid if you are not getting this. At least a little bit of understanding is also okay. As and when we are solving the problems, you will understand these 3 operations you will be perfect at. Don't worry about it. Anyhow, I'll be giving you more assignments also. You can practice it. So I hope you understood this time reversal. Okay. So with this, we have completed 3 operations on independent variable time. Okay. Any doubts? Any doubts? Please, you can ask me. No doubts or many doubts? So if you are quiet, it means either there are no doubts or lot of doubts. What should I assume? No doubt. Okay. Fine. Okay. You can check it on the screen. I have written something in the form of a note. It's very important, as we have already studied three different types of operations performed on time, that is independent variable time. You read out the note. If we have to perform two operations at a time, it may happen that, see, whenever a problem is given to you, it will not be so simple that only one particular operation is asked to perform, right? So obviously the question will be a combination of all these three operations. So sometimes it may happen that you have a question wherein you have to perform two operations at a time, say time shifting and scaling. Specifically time shifting and scaling, first two operations, like this, wherein a into t represents scaling, minus b represents shifting. If this kind of question exists, okay, if this kind of question is asked, then we have to prioritize which operation has to be performed first. Okay, you have already studied, you have been studying mathematics since the childhood, so you might have studied this rule, right? So what B indicates? You should be answering me. Please unmute and answer, no issues. Writing in the chat box will take time. B is bracket. Very good, Deepa. B is bracket. So likewise, you have O.
Order of.
Order. Okay. What is D?
Order of division, multiplication, addition, and subtraction.
Subtraction. So what it indicates actually? What it is giving you the information? You know this. Okay. So if you have a question which has all these mathematical operations at once, then which one has to be given the top priority? That priority listing is given by this rule, right? So if you have these many operations at once, first you have to start with the bracket, then check the order, then go for division, then multiplication, and so on. So as the way this is giving you the information regarding the precedence, you know, the priority given to which operation, likewise we have here two important operations, first two operations, scaling and shifting. So which operation has to be given the priority? It is first you have to perform shifting and then scaling. Remember this. Always, whenever this kind of question comes, shifting and scaling both together in a given question, you have to first go for time shifting and then you have to perform the scaling. Remember this, it's very important, because if you do it reverse, if you scale and then shift, your complete question, you know, whatever you have solved for that, completely it will go wrong. So remember, the very first step you will fall in that. So remember, you have to first go for shifting and then scaling. With this, let's start the problems on this. First question, if you have pen and paper, you can start writing. Sketch the following signal: x of t equals to u of t minus u of t minus 2. This is the given signal. Quickly tell me how many operations are involved in this question. Observe and tell me. You can unmute and answer, no issues. How many operations are involved? You can unmute and answer. Two operations. Which are those?
U of t minus
Two operations. Okay, correct. Two operations. But which are those two operations? First
U
one.
of t
Yes.
minus
Shift.
Shifting. Very good. Very good. One operation is shifting. U of t minus 2.
Minus 2.
And what is the second operation?
U of t.
No, u of t is a signal. It is not any
Yes,
operation.
ma'am. Only single is operation is involved, ma'am. Shifting.
Shifting only. Just by shifting u of t by u of t minus 2, whether you will get x of t? Look at the question and tell me. Observe the question. Yes, Deepa, correct. Subtraction and time shifting. Check this. It's very clear. You can look. There is a subtraction also. You are now in the independent variable mode. You forgot that we have even studied dependent variable amplitude also. Therein we have studied addition, subtraction, multiplication, all those. In these sessions, fresh sessions, we are studying time scaling, shifting and reversal. But earlier we have studied some other operations also on amplitude, addition, subtraction, all those. So just try to remember those. This question involves, one is a shifting operation, the other one is subtraction or addition. Okay, both are interchangeable here. So two operations are involved. You can look at the screen also. I have written addition, subtraction and time shifting is involved here. Okay, so very first thing is identification. Now you know what all to perform. Let's start. Okay, first is you have in the question u of t and then u of t minus 2. So please always have the habit of drawing the signals one below the other. Please don't consider that your paper will get wasted. Please make sure that you are drawing the signals one below the other. This is your u of t signal, right? Left side there is no amplitude. From 0 there is a step and the amplitude is continuously equal to 1. This is u of t. The first signal I have drawn it. Now, how to find u of t minus 2? Second signal. T minus 2. Shift is whether it is towards the left or the right. You can unmute and answer, no problem.
Right, ma'am.
Right side. The shifting is to the right side because you have a negative sign here. It indicates T0 value is positive, greater than 0, which is 2. Hence, shift is to the right side by 2 amounts. So, here the signal starts at 0. Shift this to the right side by 2 amounts, 0 to 1, 1 to 2. Okay. So, the new signal u of t minus 2 will start from this 2 point. Whatever 0 amplitude is there is now at 2 points. And the same thing is continued. Here see, amplitude is constant throughout, amplitude is constant throughout. So I hope you understood how to draw u of t minus 2. Okay. Now we have two signals with us. One is u of t, the other one is u of t minus 2. Okay. Now we have to perform subtraction. Subtraction means amplitude, take both the signals amplitude and subtract it. Okay. So let's start from the leftmost. Any amplitude here? We don't have any amplitude, 0. Here also we don't have any amplitude, 0. If you observe, after 0, the amplitude is 1. But you check here between 0 to 2, still you don't have any amplitude. It is 0 only. So you have to perform subtraction. 1 minus 0. you will get 1 only. Till this, only till 2, you will get 1. And after this, observe the amplitude, still it is infinite. Okay, it is up to infinity, the amplitude is 1. So here it is 1. What is the amplitude after 2 here for the second signal? It is 1. 1 minus 1. 1 minus 1 is 0. So you cut this. You end this here itself. Don't continue because the amplitude here is 1. 1 minus 1, it is 0. Hence, this small rectangle type of signal will appear as x of t. Let me just recall this problem one more time. U of t initially we have drawn. Then we went for u of t minus 2. T minus 2 is the right shift by 2 amounts. So it will start from 2. Then subtraction, here no amplitude, here no amplitude. So no amplitude here. If you observe after 0, you have 1 amplitude. Here we have 0 amplitude. 1 minus 0 will become 1 up to 2. After this, still this is 1 only. Okay, it is continuously 1. Here also after 2, 1 amplitude is existing up to infinity. So 1 minus 1 throughout completely. 1 minus 1, 1 minus 1 up to infinity. You don't have any amplitude, it is 0. So cut the signal here itself. So did you understand this problem? Any doubts here? Please, you can ask me if you have any doubts.
No, ma'am.
Okay, you understood?
Yes, ma'am.
Okay. Can anybody tell me how much time is still remaining for the second problem? How many operations are involved? You can check it. X of 3t plus 2. 3t means you have time scaling. Plus 2 means there is a shifting. So time scaling and shifting, 2 operations are there, but no addition, subtraction, those things. It's a single signal. We don't have any addition or subtraction kind of things. Only it is time dependent operations are there. That is, one is a scaling, the other one is shifting. Okay, just now I have told you, whenever here you can see there are 2 operations involved here on the time. One is a scaling by 3, the other one is shifting by 2 amounts. So when these 2 are there, which operation to be prioritized first? The precedence should be given to shifting first, and then we have to perform scaling. So let's do that. You can see I have redrawn x of t one more time. If this is the case, we start with x of t. First we shift it. Shifting by how many times? Plus 2. That is left shift by 2 amounts. So we will perform this first. So perform that. If I shift the signal to the left side by 2 amounts, I will get, this is 1, this is 2. That is minus 2 and minus 3. So the signal will be at minus 3. And here also, if I shift this, 1, 2. So it will be at minus 1. These 2 are the points. Minus 3 to minus 1, increasing and decreasing ramps. You can observe how many units are there. 1 unit, 2 unit. Here also 1 unit, 2 unit. Maximum amplitude 1. So the signal what I have drawn is correct because the amplitude has not changed. The time has simply getting shifted. Amplitude remains unchanged. So after this, once I got this shifting operation,